Good morning. Um, there's a new phrase that's being whispered in the academic labs and the research centers here in Singapore. Do you know what that new phrase is? Value capture. Now, as academics, we do a lot of very valuable things, right? We teach, we mentor our postdocs and our graduate students. We do great research, world-class research. We publish in leading journals, but that's not the kind of value capture we're talking about. We're talking about value capture in the economic sense, in the business development sense. And although Sensem has actually done quite well in this, as evidenced by some of the speakers that will talk after me about specific projects that they've been able to move into commercialization, it's something that many of us as faculty and researchers feel a little bit uncomfortable about because it's something new to us. So I'm going to talk for a couple of minutes about driving research to impact, and I mean commercialization impact, and certain tools that can be used to help you do that, such as the adaptive innovation approach that we use. So the next wave of economic development, I think we all believe, globally, will be led by innovation and entrepreneurship. Our thesis for today is that academic research can be a significant driver. In fact, it must be a significant driver of the knowledge-based economy. However, this is what we normally find. This is a historic view where the academics are on one side, fueled by grants and producing papers. The market wants goods and services acquired by customers that produce jobs and economic development, and there's this gap between the two, which has the undesired outcome that research fails as a driver of economic development. So I think we at Sensem and I think we at MIT have a different model, and that's that a world-class research like MIT is surrounded by an entrepreneurial ecosystem that can identify, harvest, and monetize the results of its R&D. In fact, the Kauffman Foundation did a recent report that if you look at all the companies that have been formed by MIT faculty and students, and in any one year you look at the revenue produced by those companies, it's over $2 trillion a year, which is equal to about the 5th largest economy. So the Deshpande Center is one of the elements on the MIT campus that helps faculty bridge this gap. And what they discovered was that jumping from the academic side with your discovery to the goods and services that's demanded by the marketplace really requires not just one single leap, but 3 small leaps. So in the T-0 is the company formation phase, which is funded by venture capitalists and angel investors. Initial team is formed, you developed your product. Then as you grow, you are funded by different kinds of investors, banks, larger venture capital groups. Your management team changes as you penetrate the global market. But what we were focusing on is prior to company formation, stuff that still will happen within the academic center, and this is the T-1 phase that the Deshpande Center focuses on. And what they realized that faculty understand the technology on a global basis very well, but where there's a little bit of a weakness is understanding the market, the needs of the customer, and how do you take your technology to produce a product that can actually address the needs of the customer. And so what we are doing at SMART is really following the Deshpande Center model. I give out about $5 million of grants a year to all the institutions of higher learning in Singapore, not just SMART or CREATE. We get about 200 applications in, and through a selection process, we pick about 24 projects that we fund. But more significantly is the direction phase, which I'm going to go into a little bit in greater detail, where we help the faculty take an initial technology, identify the market, a product that can be made by the technology that can address a substantial market, and then figure out how do you do a roadmap to actually take the technology and build that product. So at the end of our 18-month cycle, we understand the market, we understand a product that has a very good niche in that market, and we have developed a prototype so we can then connect the team to the larger venture community that can help them grow the business. This is a kind of a more noisy slide saying the same thing, but I wanted to point out that in this 18-month process here, we work with faculty and postdocs and graduate students in a number of ways. We have boot camps. We have now a 6-month innovation fellowship program. We have catalysts that are business mentors. And we have I-teams, which are MBA students that are embedded within the technical team. And all this is doing a process that we call adaptive innovation. And I'm going to describe a little bit now what adaptive innovation is. So this is a kind of a matrix that we've put together that we all use when we work on our projects. And I'm going to run through this fairly quickly. So basically, we start off with a technology that's a really good technology, but we're not quite sure what the commercial market is. We may have an initial concept, but that hasn't been proven yet. And so we do first a deep dive into the technology. We understand its metes and bounds. Who are the competing technology? What advantages do we have? And then from that, we do an opportunity matrix. What are all the possible products or markets that this technology could address? And I'm going to give you a case study about how we handle the opportunity matrix. After you analyze the opportunity matrix, you pick one product that you think is going to be the killer app, and then you do a value proposition for that product. But now we get into the more difficult thing, is we need to test that in the market. And so we need to go into this green phase here, which is really customer discovery. We teach how to do open-ended questions to customers, how to identify what their needs are, to see whether the value proposition that we've come up with is something that the customer really wants. And if it's not, then we have to pivot and find something else in our opportunity matrix. Something else in our opportunity matrix that the customer would be interested in. Once we identify that there is an interest, we dig down deeper and find, of the customer base, who is our beachhead market? Who are the customers that have the greatest need for this product? And when we listen to those customers, the voice of the customer, which is kind of a Six Sigma design process, we identify the target product profile, which is the spec that needs to be made. And then we look, can the technology meet that spec? So this whole process of identifying the product market fit is something that's very critical to success of a business. And once we do that, then we do a roadmap. We identify the resources, the personnel that's necessary to develop the prototype. We go further on and look, how do we scale that? How do we do the engineering prototype, the consumer-oriented prototype? How do we scale it? What are the regulatory issues that we need to deal with? And in parallel, we do the various 18-month cash flow, 4 to 5 year P&L, and look at the value proposition of the business. We do all this prior to a company being formed. And this is very valuable because it's enabling the faculty and the researchers to experiment with a business conceptualization phase prior to the risks of actually having some maybe leave the university or engaging venture capitalists that are not going to be so kind if you fail. So what I'd like to do now is give you a case study for that little block called Opportunity Matrix. So this is an opportunity that the technical team has to really brainstorm and try to figure out what are all the possible commercial applications that could be relevant. So this is a case study involving Doug Hart at MIT. And Doug and his couple of postdocs were looking at how fluid flows around a piston. And they wanted to look at a three-dimensional rendering of this to really understand what was going on. So they developed a really fascinating technology using a two-dimensional normal camera, putting an adapter on that, doing some signal processing, and they were able to develop very accurate 3D images about 1,000 times faster than could be done currently at that point. So we all thought, wow, this is really interesting technology, but what could the market be? So they applied for and got a Deshpande Center grant, which is similar to my grant, and they produced an opportunity matrix. They went through and they said, what are all the possible products that this technology could make? And you see there's 25 of them here. They dug into each one of them. You know, there's facial recognition, medical oncology, rapid prototyping, a number of different things. They talked to customers, they went to seminars, they did research, and unfortunately they almost gave up because none of these looked very attractive. In fact, they found out that the sexiest areas, which include areas like facial recognition and certain medical applications, were either too small or too fragmented to justify the expenditure to actually do the research and set up a company. Then they focused on machine vision, but at that point that was characterized by very small companies going after niche markets, also not something around which you want to grow a business. And then one of the members of the team went to his local dentist, and in process of getting some dental work done himself, he said, you know, do you have any problems that you and your clients face? And the dentist said, yeah, I hate to do dental impressions. If you've ever had a dental impression, you know, it's a metal plate and they put some gook on it and they jam it up into your mouth and it forms around your teeth. You sit there for a while until it dries and then they yank it out. And they use that to make plaster Paris molds so they can then do implants and crowns and that sort of thing. And he said, you know, it's very uncomfortable for my patient. It's time consuming because they have to sit in the chair waiting for it to harden. And it's not that accurate. So then he thought, wow, we have a little device, a probe and like a camera that we can put in your mouth, and we can take a three-dimensional image of your teeth very accurately. And that three-dimensional data set can be sent to, you know, the milling machines or the 3D printers and make the implants or the crowns. So they thought, this is really a good application, let's explore it. They did a further in-depth analysis and they found out, yeah, there's a lot of implants being done each year. There's 160,000 dentists just in the US alone, all of which are individual entrepreneurs basically. And the value proposition was that if you could save them money and make it more convenient for the patient, then they would buy this product. So with that, they had the Deshpande Center grant. They looked around for what their focus would be. They identified the dental market. They raised $3 million and did their initial prototype. They raised another $5 million and they actually scaled it up and were starting to introduce it into selective dental practices. And they got acquired by 3M for $100 million. So the investors were happy, and certainly the faculty entrepreneurs were very happy. And more than that, it really started a whole industry, the whole digital dentistry industry, which is the way dentistry is moving, was a result of this technology breakthrough. And it goes to point the fact that had they picked one of those other applications or one of those other products, they would not have succeeded, they would have failed. And so what we try to do is work with the faculty and the team to try to identify what is that product market fit for your technology that's going to drive a potentially successful business. So we've done quite a lot of this. We've launched 15 companies in the last few years. We have about 22 that are still in process, and we have quite a pipeline. Some of the companies up there will be presenting in the next couple of minutes. So what's the critical success factor? Well, don't do it alone. Get some mentors, either Catalyst, which we use, or iTeams, which are MBA students, or find a mentor that can walk you through this process. Adaptive innovation is a method that we use, but there are other methods as well. The key thing is to identify what are the needs of the market, what can your technology produce, and to try to find that product market fit. And it's something that's a contact sport. You know, you sometimes will have to move out of your comfort zone and actually talk to potential customers and potential competitors. It's a contact sport and it's also a team sport, so networking is very important. Start getting familiar with venture capitalists, entrepreneurs, lawyers, accountants, and we have a lot of networking events to try to make that happen. And the other key thing, if you're a faculty, involve your postdocs and graduate students. If you're a postdoc and graduate student, try to get involved with a project like this. The Kauffman Foundation in another report said the key ingredient of taking technology and moving it into a company is the postdoc who brings that knowledge and know-how with them. So this is my last slide, and this is the kind of the second phase of that cartoon I showed you earlier, where the The little cartoon figure is very happy. He had value capture. He made a successful entree into the commercial market using adaptive innovation and the other things that we've talked about. The point is that this is going to be part of the faculty and the researchers' role at this point. It's something that, and I hope that the speakers that come after me who've gone through this process with us will testify, it's a difficult process, but it's actually enjoyable. In fact, it's really a lot of fun, and it's something that I think is important for the new economy. So thank you very much.
Some questions? So what do you think are the unique things about Singapore and the academic ecosystem here that gives Singapore sort of an advantage over, say, the east coast of the US or California? What can be done here better, I guess?
Well, I think Singapore is setting it up as a test bed for urban sustainability. So I think there's an opportunity to do things in Singapore that can't be done elsewhere commercially. So for instance, and I hope I don't steal Ami's thunder, but Ami has a company, Vicenti, that makes a smart water grid technology, sensors in the grid and big data analysis. And Singapore was a showcase customer. That system has been installed throughout Singapore. It works tremendously well. That's elevated that company now into a global company with customers in Europe, in the Middle East, in China. So it's an opportunity to actually, because Singapore is small, because it's fairly, and it's made a major effort to focus on sustainable urban living, it's a great place to test bed products. Had this company been started in Boston, water utilities are very conservative, very unwilling to adopt new technology. The fact that it was adopted here on a big scale, they're all following along.
Yes, regarding involvement of postdocs, graduate students, do you have any advice for faculty on navigating what can be a complicated relationship with a dual relationship that business and academic on the other hand?
Correct. With graduate students, it's a little bit more difficult because you're worrying about their thesis, and if their thesis is the basis of the company, that can be somewhat problematic. For postdocs, I'm not sure. There may be a conflict of commitment area, but if it's a technology that the faculty member is promoting, having his postdocs who are already working on it, taking it further and developing it into a company seems like a great opportunity. I mean, again, we have some examples that we'll be talking later on about faculty that worked with their postdocs and allowed them to the freedom to really go out and develop a business around the technology that they developed in the academic world.
Well, clearly, it can be a win-win. But the question is, any advice on steering it that way? Any precautions or groundwork you would advocate?
No, I think it's, so far what I've seen, it looks like a fairly good relationship where the postdocs are the ones that actually are doing the nitty-gritty work, and therefore them transferring into the company makes a lot of sense. So I don't have any pitfalls that I can identify. Maybe some of the faculty can help out in that, but I think it's a good thing. The other thing too is that so many postdocs globally are not going to get academic positions, so enabling them to transfer into a startup company kind of situation may be a very good career path for them.
One more question.
What are your rules on intellectual property rights?
So the grant that I give is purely a grant. So the grant goes to the home institution, which is one of the institutions of higher learning here in Singapore, and they own the IP. So we don't have any claims to the IP. And it's the normal institutional rules concerning IP. Each institution has, in Singapore, has slightly different rules. But the IP is owned by the institution. Usually they permit the postdocs and maybe the faculty to form a company, and then the technology is licensed at arm's length from the university into the company.
Okay, thanks again.
Okay, thank you.